In this video, we're going to discuss understanding IP routing, or as the outline says, how do routers work? Now, so far up to this point in the IC&D 1 course, we have focused on LAN connections, which are all layer 2 connections. I send a frame out on layer 2, it has a source and destination MAC address. The switch knows which MAC address is which and sends it out the correct port. Pretty simple, pretty straightforward. However, let's expand our horizons a little bit and look beyond our local network and out to a wide area network, or perhaps out to the internet. And to do this, we'll have to explore the functions of routers and how routers work. Now, when it comes down to it, routers have two basic functions. Number one is path determination. Basically, how do I get from point A to point B? The other is packet forwarding. Once I've determined how to get from point A to point B, how do I change the layer 3 address and change the encapsulation and send the packet along its way? Now, this sounds very simple, and at its core, it is quite simple. Routers are pretty simple devices when you break them down like this. However, setting up the path determination, how do I get from point A to point B, will take years to master, especially the larger networks that you work on. And here in the IC&D 1 course, we're just going to scrape the surface of this. We're going to set up a simple routing protocol, RIP, a little later on in this section. But on large enterprise networks, you'll have multiple routing protocols that are redistributed different ways. You'll have different speed WAN links that service different networks, and it can get very, very complex to force the traffic to go the direction you want. And that's not even getting into failovers and redundancies and so on and so forth. So, how does a router accomplish its path determination functions? Well, it uses what's called the routing table. And essentially, the routing table is just a list of all of the networks that a router knows about and which interface is the next one along the path. Now, for most of the labs we're going to do in IC&D 1, the routing table will be very simple, because most of our routers will only have two interfaces on it. One for the LAN and one for our WAN interface. And so the routing table will simply know, here's all of the networks that I know about, and they all go out this serial interface or out this Ethernet interface or whatever interface we have set up. However, again, in the real world, you could have routers with multiple interfaces, multiple interface speeds, multiple interface types, and it's up to you to engineer which direction the traffic will go. So, we understand that we have a routing table, and the routing table uses the IP address and the subnet mask to determine which way to send the traffic. We'll explore this a little more in depth as we go through the labs. But when you see how the router uses the IP address and subnet mask to determine the correct path, you'll see it's pretty simple. And again, getting the right routes into the routing table, that's the tricky part. So, how do routers learn these routes to put in the routing table? There's four basic ways they can learn them. Number one is directly connected, and these are the networks that are defined in the interface configuration. If you define an IP address of 10.1.1.0 with a subnet mask of 255.255.255.0, then the router knows that every IP address that begins with 10.10.1.0 and ends with 10.10.1.255 will be off this interface. You don't really have to tell the router about directly connected routes. It knows they're there just by virtue of what interfaces are configured. Next on the line is static routes, and these are routes that are manually defined in the router's configuration. I know what you may be thinking, well, if the traffic engineering is so difficult, why don't we just have everything use static routes? Well, you'll cover that in a later section, which I entitled Static Routes and Why They Are Evil. Static routes work pretty well for a small network. Doesn't scale very well, though, and we'll get into that here in just a little bit, and we'll see how static routes don't really work on a wide scale. The next is dynamic routes. These are routes learned by routing protocols, and different routing protocols have different weights for their believability. Now, we won't really get into that in the IC&D 1 course, but if you choose to carry on with your CCNA and go through the IC&D 2 and the CCNP course, then you'll see that you can learn the same routes through different routing protocols, and the router will choose to believe, for example, OSPF more than it believes RIP. If it has the same network that's being learned via RIP and OSPF, that are going out two different interfaces, then the route that's learned via OSPF will be the one that ends up in the routing table. And again, that's getting a little more advanced, but just kind of pulling the curtain back and letting you know of some of the more advanced topics that you can expect to see later on down the line. Last but not least is the default route. This is a route that is configured or learned through a dynamic routing protocol, and it's used as the next hop if no other route to the network in question is known. If you look at the routing table on a router, it will actually tell you the gateway of last resort is A.B.C.D, or whatever that IP address happens to be, and that's what it's actually called, the gateway of last resort. If it's not directly connected, if I don't know it through a static route, if it's not learned via dynamic route, I'll just give it to this guy, and he knows how to get it along its path. So it's kind of a sample of what you're looking at here. Let's say we have these two lovely computers and they want to communicate. So they are connected to a LAN, which is directly connected to a router at each location. And these routers are connected to other routers, and those routers are connected to other routers. You can basically simulate the internet or a wide area network using all of this mess of routers here in the middle. So let's say that host A wants to send IP traffic to host B over here. So host A has a default route configured in his local host routing table that says, send everything to this guy. This guy here is connected to two other routers. Now you may think, well, it's connected to two routers. You just send half the traffic out this and half the traffic out here, and it'll eventually get there across the internet. Well, let's say that this is a DS3. This is a 45 megabit DS3, and this is a dial-up line. Would you really want your traffic going over this dial-up line if this DS3 is available? No, you wouldn't. So this router says, well, I have a DS3 available to me. It's got lots of bandwidth. It's hardly used. Why don't I send it out this DS3? This guy here is only connected to one other router. So it says, well, I know it's not this direction. The network I want to get to is this other direction. So it sends it to this guy here. Now this guy has two choices, or three really if you count this way. But it has two choices of how to get to this router over here. It can go directly this way, or it can go through here and up to this router. Now again, let's say this is a T1, a 1.5 megabit line. This is a DS3. While this path is obviously shorter, this path will probably be quicker because you've got more bandwidth available to you. So this router makes the routing determination to send the traffic over this DS3 and then up to this router and get it to this host. So as you can see, even though router functions are fairly simple, getting the traffic to follow the path you want it to follow, or follow the path that's the most logical for that traffic type, can sometimes be tricky. And that's our job as network engineers, to configure that and get that working. For now though, this concludes our discussion of understanding IP routing.